My Solar Oven Project by Melanie Durr. The materials I'll be using are tape, scissors, ruler, knife, pen, aluminum foil, plastic wrap, a cardboard box, black paper, and to test my oven out with, I'll be using fudge brownie mix put in a glass container bowl. I chose to use a cardboard box because I thought that would keep the heat in, just like our pizza box experiment. I'm still using aluminum foil, and also I added a mirror to help reflect the sunlight's heat into my oven, and everything else is self-explanatory. Step 1, measure and mark a space to cut open the flap. Step 2, use a knife to cut open the flap. Step 3, cut and glue black paper to cover the inside. Step 4, cover the flap with aluminum foil. I also taped a mirror to better reflect the sunlight into the box. Step 5, cover open space of lid with plastic. The plastic wrap didn't work, so I ended up using the plastic sheet of a picture frame. Step 6, place food item inside box with a thermometer. Step 7, put lid on. Now it's time to test it out. For my setup, I used a metal chair, a black cloth to put my oven on, and I faced it all towards the sunlight. Here is a time lapse of my solar oven. Unfortunately, during the first 30 minutes, the flap of my oven fell down, so my brownie was not receiving any thermal energy from the sun during that time. The highest temperature my solar oven got up to was about 150 degrees Fahrenheit. You can start noticing that heat is being trapped into my oven by seeing the steam inside the plastic. However, I did have trouble keeping all of the heat inside, so I decided to seal the cracks with tape. It helped a little bit, but my highest temperature still was only above 150 degrees. The total time the brownie cooked in my solar oven was about 2 hours. I checked my solar oven every 30 minutes, and in each check-in, I made sure to try to readjust my oven so that the sunlight could reflect its heat into my oven. The energy transformations started from potential energy, nuclear energy, transferring to radiant energy from the sun, then to thermal energy as the heat is contained into my solar oven, and then I decided that it transferred to motion energy because I saw the steam move from different areas in my solar oven, and then finally to chemical energy because of the somewhat cooked brownie I made. So as I said before, here are the results. The brownie cooked on the top slightly, but as I dipped the toothpick into the center, it was still gooey, so it wasn't fully cooked. In conclusion, my brownie showed signs that it cooked, however, the gooey center concludes that it did not fully cook. This could be due to the lack of time, heat of the oven escaping, position of oven from the sun, and or placing the oven on a metal chair. Therefore, to better improve my solar oven project, I will seal cracks of my oven, choose a different food to cook, and place my oven on the ground and readjust positions more accurately. Thank you for watching. Suggestions are welcome. My solar oven project, second attempt. After taking some time to think about my project as well as listening to the feedback from my peers, I decided to use electrical tape to help seal and keep the heat in of my oven. I also decided to use a different holder to hold up my reflector in my oven. I originally used a toothpick, but I decided to use marbles and tape it to the reflector, adjusting the angle according to the sun. Instead of making brownies again, I decided to make nachos and compare how hot my new and improved quote-unquote oven will get in relation to the pizza box oven I made in class. Unfortunately, my quote-unquote new improved oven only got up to 125 degrees Fahrenheit. That is about 20 degrees less than the pizza box oven I did in class, as well as my first attempt in this video. Some factors that I think may have affected my quote-unquote new improved oven was maybe the electrical tape didn't help seal my solar oven and to contain the heat. Although you do see some steam moving throughout the time lapse, which means that there was heat at some point in my solar oven, but also at the end of the time lapse, the steam starts to decrease. So something went wrong, which makes me think that weather is also a huge factor of why my solar oven may have not gotten to the highest temperature it could. It was 20 degrees colder than it was on my first attempt, as well as the attempt we did in class. It was actually about 60 degrees, maybe 50, 55 degrees Fahrenheit on my second attempt, which makes sense because my quote unquote new and improved oven decreased by about 20 degrees, so maybe the weather was a huge factor. I still believe that the energy transformations in my second attempt remain the same, from nuclear energy transforming to radiant, transforming to thermal, motion because there was still steam moving within my solar oven, and then to chemical um, because the cheese did look slightly melted, but not all the way. It was also very windy and, as you can see, partly cloudy. So I assume the radiant energy may have not transferred into my solar oven as well as it could have or did on the previous attempts. So hopefully next time, if I ever get a chance to recreate or improve my solar oven, I can reach a higher temperature than 150 degrees and actually cook some yummy food. Thank you for watching, and I hope you enjoyed. Bye!